Here we have some questions on the friction. The first question says, a wooden block of mass 1.6 kg rests on a rough horizontal surface. If the limiting frictional force between the block and the surface is 8 Newton, calculate the coefficient of friction, given that gravity is equal to 10 meters per second squared. The first thing we have to do is to list out all the values given in the question. Mass of block 1.6 kg. The block is resting on a horizontal surface. So an object resting on a horizontal surface has zero acceleration. If the limiting frictional force between the block and the surface is 8 Newton, frictional force is 8 Newton. And the gravity given is 10 meters per second squared. After listing out all the values given in the question, we move on to drawing our motion diagram. Object on the rough horizontal surface. This is a typical diagram of an object on a rough horizontal surface. Mass of the object 1.6 kg. Vertically downward we have the weight, mass and gravity, which is equal to 1.6 kg times 10 meters per second squared equal to 16 Newton. Vertically upward, we have the normal reaction. In this case, both the normal reaction and the weight are parallel to each other. So we say the weight is equivalent to the normal reaction, which is 16 Newton. Here we have the value of the frictional force to be 8 Newton. For us to have the value of the frictional force, there must have been a particular force applied to the object. So let's assume this is the direction of the applied force, either pulling or pushing force. And this would be the direction of the frictional force. So if this is the direction of the applied force, the direction of the frictional force will be opposite to it. So the question says, calculate the coefficient of friction. Formula for finding the coefficient of friction is mu equal to friction over normal reaction. The value of our friction is 8 Newton. Normal reaction is 16 Newton. Then we have 1 over 2 equal to 0.5. That's the final answer. That's the value of the coefficient of friction in the first question. Now, the second question says, calculate the magnitude of the force required to just move a 20 kg object along a horizontal surface if the coefficient of friction is 0.2, given that gravity is equal to 10 meters per second squared. Let's list out all the values given in the question. To just move, magnitude of the force required to just move. To just move, in this case, the object hasn't moved. We consider the object to be at rest, like not to move. It is about to move, but it hasn't moved. So we say the acceleration is 0. Mass of the object is 20 kg. If the coefficient of friction is 0.2, coefficient of friction 0.2. Gravity is 10 meters per second squared. So the next thing to be done is to draw out our motion diagram. So horizontal surface 20 kilograms. Vertically downward we have the weight mg, which is equal to 20 kilograms times 10 meters per second squared. This is 200 Newton. Vertically upward, we have the normal reaction. Vertically upward, we have the normal reaction. And since this is on the plane surface, the weight is equivalent to the normal reaction, which is equal to 200 Newton. In this case, we are asked to find the magnitude of the force required to just move a 20 kilogram object. The magnitude of the force required. Alright, the formula for the coefficient of friction is mu is equal to frictional force over normal reaction. Making friction a summation of the formula, we have friction is equal to mu times normal reaction. In this case, let's assume this is the direction of the applied force should the force is applied. For us to have coefficient of friction, that shows we have friction. And for us to have a friction, there must have been a particular force that has been applied to the object. So let's assume this is the direction of the applied force and this is the direction of the frictional force. In this case, don't forget we said we consider the object to be at rest since it is about to move the object. Not yet, it hasn't moved yet, so we consider it to be at rest. Same principle as when an object is at rest. In this case, the resultant force, if acceleration is 0, the resultant force is going to be 0. So once the resultant force is 0, that shows that the pulling force, which is the applied force, is equal to the frictional force. When the resultant force is 0, the applied force is going to be equal to the frictional force. So in this case, we replace F, the friction here, with the applied force, since the frictional force is also equal to the applied force. So we replace F with P in the formula. Then we say P is equal to coefficient of friction times normal reaction. In this case, our P, which is the applied force, is equal to the coefficient of friction, which is 0.2 times normal reaction. The normal reaction is equivalent to the weight, so 200 Newton. 0.2 times 200 Newton, we have 10 Newton. Therefore, the applied force is equal to 10 Newton. That's our final answer for the second question. The magnitude of the force required to just move a 20 kilogram object along a plane surface is 10 Newton, the applied force.